When we gaze at the sky, it's easy to perceive it as an unchanging backdrop, a constant scene where the saga of human advancement unfolds. Yet from time to time, a faint trail of light emerges. This serves as a gentle reminder that the universe is vibrant, unpredictable, and populated by visitors hailing from far beyond our solar system's confines. Such was the case on the night we registered 3I Atlas in our datasets. It didn't make a grand entrance, lacking any spectacular display or brilliance. Instead, it materialized as a faint, swiftly moving point of light among a series of exposures from the Atlas survey. Labeled 3-2, it was recognized as the third confirmed interstellar object detected by humanity. In the realm of science, familiarity brings comfort. Comets, asteroids, planets, and stars. However, interstellar objects remain foreign to us. They lack the chemical lineage of our solar system and do not conform to the orbital paths as described in textbooks. Their existence compels us to pose questions that we might otherwise avoid. What constitutes normal in a universe that we are just beginning to explore? As astronomers gathered more data on 3I Atlas, it became evident that this object, akin to Oumuamua before it, was not going to fit neatly into our conventional categories. Nature was presenting us with another riddle. As 3I Atlas neared perihelion in late 2025, telescopes worldwide, both amateur and professional, began capturing progressively detailed images. Most interstellar objects brighten as they approach the sun, with sublimation intensifying, jets becoming more defined, and tails lengthening. However, 3I Atlas did not follow this usual pattern. Observers noted an unusual feature: two thin linear structures extending sideways, forming a subtle X pattern when set against the direction of solar illumination. In my own analysis, I referred to these characteristics as sideways lines, distinctive because they failed to align with the typical tail and anti-tail axis one would expect from solar radiation pressure and outgassing dynamics. In astronomy, orientation is crucial, as physics leaves distinctive signatures. Jet formations are not arbitrary. The images captured by Michael Jagger, utilizing 2,100 second exposures stacked meticulously to enhance signal-to-noise ratios, revealed something that commanded attention. The lines were genuine, evident across multiple exposures, not artifacts of the camera, and significantly, they extended perpendicular to the anticipated dust trajectory. This is unusual, not unprecedented, but rare enough to necessitate an explanation. When faced with an anomaly, our instinct should not lean towards speculation, but rather careful analysis. Science progresses by ruling out potential explanations methodically until only the truth remains, regardless of how surprising it might turn out to be. Thus, let's explore the possibilities. Firstly, there's the idea of conventional comets release gas and dust when heated by the sun, which can generate jets in various directions, contingent upon surface composition and rotational geometry. It's entirely feasible that 3I Atlas is shedding material from areas on its surface that face away from the primary tail's direction. However, the symmetry and definition of the lines suggests they do not result from a random arrangement of events. Secondly, fragmentation release could be a valid explanation. The sideways lines might illustrate the path of small fragments drifting from the nucleus. This phenomenon is common in vulnerable or loosely bound cometary bodies. Yet, interstellar travelers face stresses that locally formed objects do not, including gravitational tidal forces, thermal gradients, and cosmic irradiation. Thirdly, there's the possibility of ejected secondary objects. In my Medium post, I noted that the sideways lines might indicate the release of smaller fragments. Not an extraordinary claim, but rather a hypothesis consistent with observational data. Compact fragments moving perpendicular to the sun's direction could create this specific appearance if their release was impulsive or synchronized with the object's rotation. Fourthly, the lines might be reflections from solid fragments instead of dust streams. The narrowness of the streaks implies compact sources rather than diffuse jets. When Oumuamua traversed the inner solar system in 2017, the scientific community initially tried to classify it as either a comet or asteroid, but its characteristics resisted such categorization, showing no visible cometary tail, no dust emissions, and non-gravitational acceleration, along with an extreme aspect ratio suggested by its brightness variations. Because of this, I have contended, and continue to contend, that we should maintain an open mind, not imaginative or speculative, but receptive to the wide array of possibilities that nature presents. With 3I Atlas, we face another peculiar signature: sideways jets that defy typical solar-ejected patterns. The lesson from Oumuamua is not that every anomaly is artificial or extraordinary. Rather, it is that the universe holds more complexity than our preconceptions allow. When confronted with unexpected data, the scientific method does not prompt us to dismiss or embellish. It urges us to analyze deeply. In physics, direction provides as much information as magnitude does. The sideways lines in the Atlas images represent more than just aesthetic details. They encode vital physics. Take into consideration the geometry. The direction of the sun is toward the lower left. with the primary tail aligning with the anticipated dust pressure pathway. The anti-tail points opposite, yet the sideways lines run exactly perpendicular to this axis. This configuration is not a product of random noise. One might conceive of several scenarios aligning with this pattern. A spinning body with active surfaces if Atlas is rotating. Surface vents not aligned with its principal axis could emit material sideways, which would generate jets at right angles to the sun's direction. If the rotational phase coincides with jet emissions, discrete fragment ejections could occur. Small solid fragments separating at moderate velocities might display the sideways drift perceived as a line across stacked images. Moreover, radiation pressure segregation plays a role. Small particles react differently to solar radiation than larger ones do. If the released material is compact and dense, it may not be pushed into the main tail, thus explaining the perpendicular orientation. Each of these hypotheses merits investigation, and none require extraordinary assumptions. Though thorough modeling is crucial, in many of my public lectures, I emphasize to students that science evolves not through certainty but through curiosity. The universe does not owe us consistency. It only presents data, and it's our duty to heed it. Sideways jets in an interstellar object present not a crisis for astronomy, but rather an opportunity. They encourage us to juxtapose theory with observation, to investigate why material moves perpendicularly to solar illumination, and to ponder how objects formed around different stars might behave in dissimilar ways compared to those created here. We cannot presume that other planetary systems adhere to the same principles as our own. Their chemical compositions, thermal histories, and cosmic environments all diverge from our knowledge. When nature unveils an unusual pattern, humility guides us to explore rather than dismiss it. The importance of 3I Atlas transcends its jets or its sideways formations. It embodies something more significant. It represents the burgeoning population of interstellar objects that are now within our observational grasp. Prior to 2017, we had no confirmed examples. Now, in under a decade, we have 3. This hints at a far larger collection of objects moving through the solar system at any moment, each carrying the chemical legacy of distant suns. Fragments shaped by cataclysms that predate Earth's formation, they serve as samples of worlds we may never directly witness. Every interstellar object is a messenger, literally a piece of another world. 3.1 Atlas contributes a new chapter to this narrative. Its sideways jets challenge our existing models. Its fluctuating brightness curve prompts fresh inquiries. And its behavior near perihelion enhances our understanding of what interstellar visitors may look like. As I observe the sideways lines in the November 2025 images, I'm reminded of a fundamental truth. The universe has no obligation to conform to our expectations. We are transient observers of an age-old cosmos, and our role is not to dictate how objects should behave, but rather to observe how they actually do behave. 3I Atlas, with its unexpected geometry, teaches us once more that discovery often starts where certainty ends. Perhaps these sideways jets are merely a product of outflows, or perhaps they are fragments breaking off from a loosely bound body. Or, as is often the case, perhaps they remind us that nature frequently surprises us in ways we couldn't foresee. The true beauty of science lies not in the answers we possess, but in the unanswered questions that linger. As 3I Atlas journeys away from the sun, carrying the traces of a star we may never pinpoint, one fact becomes clear. Every interstellar object represents a dialogue not just between scientists and the sky, but between humankind and the universe itself. A serene exchange across cosmic distances urges us to listen, measure, contemplate, and above all, remain ever curious.